We talked about matter being conserved. Energy is also conserved. So what we call the law of conservation of energy, which this probably should have been in bold, but oh well, I'll underline it. The law of conservation of energy. Energy cannot be created nor destroyed, but it can be converted from one form to another. So there's two broad categories, kinetic energy, potential energy, but within those there are these 6 different forms of energy. There's heat, light, electrical energy, mechanical energy. I'm trying to say mechanical engineer, I guess, because my brother's a mechanical engineer. Mechanical energy, chemical energy, and nuclear energy. So those are all different forms of energy. Energy is associated with physical changes of state. So here we have a diagram looking at changing the state of water. So here we have 1 gram of liquid water. In order to turn that into steam, we have to put energy into it. To heat water and cause it to boil, which is the transformation from liquid to gas, you put it on the stove and you turn on the burner. You put heat into it. The amount of heat needed to vaporize or transform this from a liquid to a gas for 1 gram of water is 540 calories. So that's energy absorbed by the water to become the steam. If we take that 1 gram of steam and want to cool it down to form 1 gram of liquid water, it will release that same amount of energy. You put energy in, you take energy back out when you do a state change. And so this is a demonstration of the law of conservation of mass. You can't gain energy or lose energy by doing a transition like this. Now, not all processes are 100% efficient. The energy that is released when you burn gasoline in your car generates heat and causes the pistons in your motor to move, which, go through the crankshaft and the drive shaft and they turn your wheels, right? But it's not 100% efficient. You don't transform all of that potential energy from the gasoline into kinetic energy of your car moving. That doesn't mean that energy disappears. It's just being transformed into forms of energy that are not necessarily useful. What happens to the temperature of your engine when it's been running for a little bit? It gets hot. That's energy that comes from the gasoline. And it's not useful, is it? It just makes your engine hot, and you actually have to have the radiator and all kinds of other stuff to keep it from getting too hot. So in that process of transforming the potential energy in the gasoline to kinetic energy of your car moving, some of that we say is lost to heat energy, but only lost in terms of being useful. It's still accounted for. Okay. So law of conservation of matter, law of conservation of energy. These two actually combined together, and Einstein was instrumental in this. His theory of relativity relates energy and matter. This is energy equals mass times the speed of light squared. And I'm not going to we don't have to memorize that. We're not going to do any calculations. But he realized that mass and energy can be interchanged. So some of these laws that we have, Lavoisier came up with the law of conservation of matter. Matter can't be created or destroyed. And later we realize, well, actually, and so we have to modify the law and put some qualifications on it. And that's why it says matter cannot be created or destroyed in a chemical or physical process. It turns out in a nuclear process, you can destroy matter. But it doesn't disappear, it gets converted into energy. And so energy and matter can be interchanged. And so when we combine the law of conservation of mass with energy, we say the total mass and energy of the universe is constant. And this one is completely true to the best of our knowledge. The other laws are going to be absolutely true for anything that you could do in a chemistry lab. In an undergraduate chemistry lab, they're not going to have you do nuclear chemistry, okay, because that requires, for one thing, a tremendous amount of paperwork, right? But some very, very specialized equipment and training, and it's very dangerous. And so that's this little tiny piece that we don't deal with very much. So most of the time, law of conservation of matter and energy separately are fine, but the real deal is this guy altogether. There's the end of chapter 3.